So, Don, the floor is yours.
Thank you very much, Zach. Greetings from Woburn, Massachusetts. As Zach indicated, I've been with ArborJet now for about 7 years. I was with the Texas Forest Service for 17 years as coordinator of the Forest Pest Management Cooperative. Chris and I met when I was doing my PhD in entomology through Virginia Tech. I was doing research on southern pine beetle pheromones and geographic variations of different pheromones across the range of the beetle. And Chris was kind enough to help me out, gather data, be my support for when I was stressed, and say least, we got along very well. So we worked together for about, I think it was 2 years, and I went on my way to Texas with the Texas Forest Service. I was doing a number of different projects. I became interested in systemic injections, and I'll tell the story a little bit in more detail in just a few minutes, but in 2005, Chris and I reconnected, looking at systemic injections as ways of protecting trees against bark beetles, and we'll describe that further. So, so ever since 2005, we've been working together on and off, and we're still working on projects together at this time. So moving on, let's see, hopefully I'm going to get this going. Okay, to start off with, I wanted to kind of just talk briefly about factors that affect trees. All living things, there's a constant struggle to thrive, let alone survive. And these organisms, whether it be trees, insects, animals, they're all trying to find essential nutrients and such. And on occasion, with regards to trees, there's always deficiencies, whether it be water, nutrient, sunlight, temperature, and on occasion there's too much of it, particularly water and other things. These organisms are all trying to deal with natural forces as well, wind, lightning, fire, and the like. So in addition, trees, they're also targets for insects, disease, and weeds, because these organisms are after what these trees have, whether it be energy, serve as a host, other things like that. So bark beetles is another system that is impacting trees, and we're going to focus on conifers. Let's see. So okay, it's not responding. Are you seeing conifer bark beetles on the slide, Chris? No. All right. Okay, I'm trying to advance, and it doesn't seem to be responding. What am I doing? Any?
Hey, Don.
Oh, there we go.
Okay.
I don't know why. Okay, bark beetles, conifers. So bark beetles are just a group containing over 6,000 species across the world. This group was originally considered its own family, Sculidae, but it's now considered part of the family of Curculionidae, which are true weevils. And that's going to play into a little bit of how we did some of our research and came across the way of trying to protect trees against bark beetles. The bark beetle does refer to the fact that some of these insects are burrowing into the inner bark layer underneath the bark. However, there's a number of different members that are also part of the bark beetle group, or Scelidonae, but they in fact bore into the wood, into fruit, and other herbaceous plants. So such a group might be ambrosia beetles or coffee berry borer. These are insects that are not true bark beetles, but they're part of that Scelidonae group. Today we'll focus on conifers as host of some of these bark beetles. As examples of conifers, we're talking about cedars, cypress, firs, hemlock. A lot of our work deals with pine, bark beetles, as well as spruce. But all of these different types are included in the conifer group. And all of them have tracheal tubes. Many of them have resin ducts. And that plays into tree defense. But there is a large number of bark beetles that do focus and provide or use conifers as hosts, including Dendroctonus species, which cause most of the losses in commercial forests, as well as Ips Engravers that primarily damage stress trees in urban settings. So we see, okay. So how do you know whether or not a tree is being attacked and colonized by bark beetles? And these are just some symptoms that can be observed. Pitch tubes, boring dust are common signs of bark beetle activity. If you were to pull the bark off the tree, you'll find these galleries, as well as perhaps larvae and eggs. These are egg galleries that the adults produce. This is where they lay eggs and the larvae start to develop. After development, the new adult progeny will emerge, and you'll see these emergence holes on the bark surface. In many cases, woodpeckers will prey on bark beetles, and so you'll see the woodpecker activity on the bark surface. Other signs include as the tree dies and the foliage starts to fade, the color will change from green to yellow to red. So red is dead is a common descriptive term for trees that are killed by bark beetles. And if you were to cut some of these trees down, you'll notice a large number of them will have this blue staining within the active sapwood. And this is a fungus that is often vectored by the bark beetles, and in some cases play a part in tree death and aid the insects in colonizing the trees. Let's see. Okay. Why is this? I apologize. My computer is not responding. Okay, where are we? Okay. So bark beetles, as I mentioned, there are a large number of important beetles include Dendroctonus species, Ips Engravers. There are a number of, or a few other genera, including Dryosotes and Scolitis, that include bark beetles that colonize other trees. If you can see on this slide, the highlighted species, mountain pine beetle, engravers, these are considered some of the top bark beetles that were listed in this insect and disease force risk assessment. So again, the highlighted beetle species are probably some of the most important, causing the most mortality across the United States. Okay. So I'm going to spend some time talking about some of the southern pine bark beetles that I have more experience with. In a little bit, Chris will take over and discuss some of the western bark beetles that he's had more experience with, and then we'll get into some of the control options that are available and pass the baton back and forth. So with southern pine bark beetle, we have a guild that contains 5 different species, 3 of which are Ips Engraver Beetles and 2 are Dendroctonus species. The most important species, of course, at least in the southeast, is the southern pine beetle. This beetle causes by far the most tree mortality in the region, killing millions of trees in a given outbreak period. The Ips, they differ between each other. Ips versus Dendroctonus. The Ips have these deep cavities that are lined with spines on their hind end, whereas the Dendroctonus are rounded. They have different biology and life cycles. The Ips engravers, the males will be the initial attack sex, and then females will come in and the male will mate with multiple females. With Dendroctonus, the females are the attacking sex, and males, she'll only mate with a single male that is attracted by some of her pheromones. So talking specifically about southern pine beetle, again, this is the most important species in the southeast United States. You can see the range of this insect, primarily from East Texas to Florida and up north, originally to New Jersey, but recently this insect has expanded its range into New York, and we're finding collecting specimens as far north as Massachusetts. Again, additionally, this insect occurs in Arizona down through Central America to Nicaragua. This insect has anywhere from 2 to 7 generations per year. It's generally 2 generations in the far north versus 7 generations or more as we go south. Let's see. A distinguishing characteristic of southern pine beetle is the fact that southern pine beetle have S or meandering galleries, S-shaped galleries. None of the other southeastern species have this distinctive gallery. So if you're looking under the bark and you find S-shaped galleries, you've got southern pine beetle. Again, this insect is a very important problem. Historically, this insect has had major outbreaks on a 6 to 8 year interval from the 50s through the 90s. The last major outbreak was in the late 90s in Georgia, Virginia, North Carolina, into Tennessee and Kentucky. Here we see an outbreak that developed in East Texas. in over-mature stands. And once this insect starts building populations, it just explodes. So this is a single infestation that has spread to about 2,000 acres. Interesting enough, the outbreaks have kind of subsided, at least at this point, in much of its original range. We rarely see any activity in East Texas, which historically was one of the hottest areas in the past, but it's still not really understood as to why the cycles have changed over time. Let's see. Moving on, another Dendroctonus species, the black turpentine beetle. Okay, I'm sorry for the black turpentine beetle, another Dendroctonus species, somewhat similar range as the southern pine beetle, but their populations will extend up into Maine, where they'll attack pitch pine and other species. Black turpentine beetle is not as aggressive as southern pine beetle, even though it's a much larger beetle compared to southern pine beetle. It's not quite as aggressive. It primarily attacks low on the bole. It produces these large pitch tubes and kind of almost question mark galleries under the bark. Very important or significant pest in naval stores and frequently attack stress trees. On occasion will kill trees, similar to southern pine beetle. Ips engravers are, again, we have 3 species in the southeast. The smaller southern pine engraver is Ips avulsus. We have Ips grandicoldus, which is the 5-spined Ips. The largest is calligraphus, which has 6 spines compared to the others. All 3 of these primarily attack weakened trees. And though the avulsus tends to be a little bit more aggressive than the other 2. Let's see. Okay. This is what originally looked to be a pretty healthy tree. However, you can see obviously the upper crown has been killed while the lower crown is still surviving. This is very characteristic of attack by Ips avulsus. They attack the upper crown. Grandicoldus is more middle crown, and then calligraphus is lower crown into the lower bole. The question might be well, I mean, generally the tree looked pretty healthy. Why is it stressed? Why is the insect attacking this tree? Well, look under the tree. You see all these cars parked under the tree. And so it's probably likely that the soil surrounding the tree is very compacted. There's little water moving or available to the roots. The tree becomes very stressed, and then the insect comes in and takes advantage. So this is a common occurrence in the South, particularly under drought conditions, where trees become susceptible to bark beetle attack. Chris, if you want to move forward with the western bark beetles, can you take over?
Sure.
Or
can you advance me to the next slide, please?
I will. How's that? Can you see that?
Not yet.
Okay, I'm showing your pile of bark beetles.
There we go.
Okay.
Yeah, got it. Okay, thanks, Don, and thanks, Zach, for that introduction. As Don mentioned, he asked me to talk a little bit about the Western bark beetles. And as he mentioned, bark beetles in general tend to be this very large, diverse, and fascinating group, greater than 6,000 species worldwide, greater than 550 in North America alone. In fact, there's greater than 230 species right here in the state of California, where I'm participating from today. As you might imagine, we tend to focus on a much smaller subset of that much larger group, and those are species that we consider to be economically important. That is, under certain circumstances, and Don went over a few of those already, they are capable of causing large amounts of tree mortality. And so Don shared with you the species in the Southeast, about 4 or 5 in number. Here in the West, we're blessed with a much larger diversity, somewhere on the order of about 15 to 20 species might actually meet that definition. And in general, we tend to see much larger impacts from bark beetles here in the West than we do in the Eastern United States. This might be a fictitious rendition of a bark beetle outbreak, but there are cases here in the West, particularly with mountain pine beetle and some of our lodgepole pine systems, where populations get so large that we actually see accumulations of beetles, for example, occurring on a shoreline along mountain lakes. Next slide there, Don, if you could.
That work for you?
Yeah, not yet, but soon, I assume.
Yes. How about that?
No, I'm still seeing the dump truck.
Just showed up on my screen, so.
Okay, good, great,
See ya.
thanks. So in general, when I talk about the Western bark beetles, I like to emphasize that in recent history, we've really seen a tremendous amount of activity. And in fact, if I consider the data as a whole, I come up with what I consider to be 4 grand champions. These are bark beetle outbreaks of a magnitude and or extent we haven't seen in at least recorded history, all of them occurring very recently. And I'll go into the top 3 in a little bit more detail, but the first one I have listed there is this Western pine beetle outbreak here in the state of California. Much of that focused on the central and southern sea areas. There, that species killing over 147 million trees in about the last decade. Now, each of these outbreaks have an inciting factor that we can link to climate change. Here, it's this very excessive drought that occurred during a period of very high temperatures. To put that into perspective, 2014 was the hottest and driest year on record in the state of California. 2015 was the 2nd warmest and 3rd driest. And in fact, now we have some data suggesting that this was the most significant drought event in probably the last 1,200 years. Second one I have listed here is this very large mountain pine beetle outbreak, really throughout most of Western North America, several different hosts involved. To date, greater than 27 million hectares have been impacted. To put that into perspective, that's an area larger than our 11 smallest states, South Carolina on down, combined. Here, the trigger, an increase in temperature, but specifically winter temperatures, have allowed for a higher proportion of that population to survive the winter and contribute to the next generation. The third I have listed here is a spruce beetle outbreak in the 1990s on the Kenai Peninsula in south central Alaska, where that species essentially killed all susceptible Lutz spruce. And some of you may not be familiar with Lutz spruce, but is this naturally occurring hybrid between Sitka spruce and white spruce in that area of the world. The trigger here, once again, is an increase in temperature, but more specifically, summer temperatures have allowed a portion of that population to go from a 2-year life cycle to a 1-year life cycle. And you can imagine the implications of that to population dynamics over time. And then on the bottom here, this very large pinyon pine mortality event in the early 2000s throughout most of the southwestern United States, particularly in what we call the 4 corner regions of Arizona, Colorado, New Mexico, and Utah. They're attributed to an interaction, once again, between heat and drought and another bark beetle that we call pinyon Ips. Next slide, Don. Okay, this is just a little information on the mountain pine beetle, regarded by many to be the most significant forest insect pest in North America, if not in the world. It is the most significant natural mortality agent of lodgepole pine, but it does have a very large host range compared to most bark beetles. Now it's been documented to colonize 15 different species in the wildland system, both pines as well as a few spruce species as well. You can see the geographic distribution goes from the Pacific coast east to the Black Hills of South Dakota, all the way down into northwestern Mexico. We have seen an increase in the geographic distribution of this species. It was first recorded in Alberta, Canada in 2003, in Nebraska in 2009, and in the Northwest Territories of Canada in 2012. Usually there is one generation per year. There's been some talk about acceleration of what we call volcanism as a result of climate change, but at best we've observed the beetle to complete 3 generations in a period of 2 years. Tremendous amount of tree mortality. Most of that peaked here in the West in 2007, although it is still ongoing in certain areas. And if we reference the National Forest and Forest Insect and Disease Risk Assessment, they project that we're going to lose another 290 million square feet of basal area to this species by 2027 alone. Next slide, Don. This is just kind of a depiction as to some of the large scale impacts. I believe this picture was taken in interior British Columbia during the very initial stages of what became a very large mountain pine beetle outbreak in their lodgepole pine component. Next slide, Don. This is western pine beetle, a species I spent a lot of time working with, a significant mortality agent of mature ponderosae as well as coulter pine. You can see the geographic distribution essentially extending from the Pacific Northwest all the way down into northern Mexico, generally somewhere on the order of about 2 to 4 generations per year. There's been, again, some talk about an increase in volcanism with this species. We really haven't yet been able to document that. I talked earlier about the tremendous amount of tree mortality we've experienced in California in the last several years. That peaked in 2016 when a little over 2.2 million acres were impacted. And again, if we reference the risk assessment, here we're projecting that we're going to lose about 67 million square feet of basal area by 2027 to this species alone. Next slide. This is a spruce beetle, again, another species we spend quite a bit of time working on, the most significant mortality agent of mature spruce throughout North America. Here, a very large geographic range extending from interior Alaska all the way to the maritime provinces of Canada, all the way down into some remnant populations in the southeastern United States. Generally, the life cycle is somewhere between 1 and 3 years. Again, I talked about an increase in volcanism attributed to climate change, which has accelerated their life cycle in many populations that were once bivoltine or now univoltine. Tremendous amount of tree mortality in recent history. We have a large outbreak of spruce beetle kind of winding down in the state of Alaska right now, where it's impacted almost 2 million acres. And once again here, the risk assessment suggests that additional losses will occur somewhere on the order of about 215 million square feet of basal area by 2027. Next slide, Don. Okay, Don asked me to talk just a little bit about some of the management techniques that are available. We generally refer to these as indirect and direct control. Indirect control is preventative. It focuses on forest and forest conditions over time. The biggest thing we tend to focus on is thinning, but there are also other important considerations, such as planting the right tree to the right site, fertilization, reducing competition, pruning, maintaining adequate soil moisture, reducing soil compaction, as Don mentioned earlier, and obviously preventing damage to the roots and stem. Those obviously very important within the urban environment. In terms of direct control options, I call this kind of the Band-Aid approach, short-term tactics to reduce current infestations. We generally divide them into mechanical versus chemical. Mechanical, for example, would be something like sanitation, where we go out and identify trees that are currently colonized by bark beetles, fell those trees, and destroy the brood within them in an attempt to reduce the local abundance of bark beetles. Don didn't mention earlier, but he showed you a southern pine beetle spot. One of the primary mechanisms of dealing with those spots is cut and leave or cut and remove, where we fell currently infested trees, as well as a buffer of trees at the head of these spots, and that disrupts spots' growth over time. Also in this context, we might talk about sanitation, salvage, and those types of issues as well. The other main focus we have available to us is chemical control. That focuses on either semiochemicals. Semiochemical is simply a chemical released by one organism that elicits a response, usually behavioral, in another organism, as well as the use of insecticides, whether applied as bole sprays or more recently systemic injections. And I'll focus on the first two, and Don will take over once we get to systemic injections. Don, next slide, please. Yeah, this is just an example of thinning. Stocking, and whether we measure that as tree density, basal area, stand density index, host abundance, and tree age are consistently linked with the occurrence and severity of bark beetle infestation. Very well documented in the scientific literature for several different systems, and as no surprise, therefore, thinning is one of the primary indirect control methods of bark beetles, and that's what's depicted here. This appears to be a Loblolly pine stand somewhere in the southeastern United States. In this system, generally we argue maintaining your stands somewhere between 80 and 100 square feet of basal area to the acre. In the West, when we're talking about ponderosa pine systems, we generally argue to maintain those stands at about an stand density index value of about 230. We use stand density index just because there's much larger diversity in the size of our trees here in the West. And more recently, we've been seeing evidence that suggests we need to be managing our ponderosa pine stands at much lower densities than we considered in recent history, accounting for the increase in stress in these systems due to climate change, particularly drought, as well as increases in bark beetle populations. The reason thinning is quite effective is really threefold. First, you reduce competition. That increases tree vigor and obviously resistance and resilience to bark beetle infestations over time. Secondly, you affect the microclimate, which negatively impacts host finding. And finally, you increase inter-tree spacing. A bark beetle's job is to get from one tree to the next tree as quickly as possible. The longer they take to do that, the less successful they are in finding a new host. Next slide, Don. Semiochemicals, again, a chemical released by one organism that elicits a response in another. These are just a few examples of various formulations that are used and available to us today. On the top left there is the pouch. In the center is a biodegradable formulation known as Splat Verb. We brought that to market back in 2005. And on the right is our laminated flakes. These can actually be applied airly as well. Next slide, Don. Verbenone receives the most attention. It is the principal anti-aggregation pheromone of the southern pine beetle, mountain pine beetle, as well as the western pine beetle. As best we can tell, it inhibits additional beetles from infesting the target tree, limiting the number of beetles to a density that increases the likelihood of their survival within the tree. First registered in a pouch formulation, a 5-gram pouch formulation, back in 1999 for southern pine beetle. Today is used quite extensively for mountain pine beetle, as well as southern pine beetle, and to a much lesser extent, western pine beetle. Next slide. And obviously the other anti-aggregation pheromone we have available is MCH. This only used in the West. It's the principal aggregation pheromone component of the Douglas fir beetle, as well as the spruce beetle. Works very well for Douglas fir beetle, much less so for spruce beetle, but several of us are now working on combining this anti-aggregation pheromone with other repellents to increase efficacy for tree protection for spruce beetle. Next slide now. Insecticides, I want to be very clear that here we're talking about prevention, not suppression or what we might have called remedial control. We're talking about applying these materials in advance of the trees being challenged by bark beetles. An example of me doing that here on the right, I'm treating a ponderosa pine tree here in Northern California with bifenthrin to protect it from colonization by western pine beetle. Here in the West in particular, during large outbreaks, we may treat hundreds of thousands of trees annually with bole sprays. Generally, again, just trees in unique circumstances, high value trees in residential areas, recreational areas, administrative sites, progeny tests, perhaps seed orchards, and in some cases, those that might be identified as genetically resistant to forest diseases. So for example, here in the state of California, many of our sugar pine that are resistant to white pine blister rust have been identified on the landscape. And during large infestations of mountain pine beetle, these trees may be treated either with verbenone or an insecticide to protect them during that period of time. Reason being is these losses in these environments and unique circumstances really have a lot of undesirable effects. And in most cases, therefore, protection of those trees are justified. Next slide, Don. This is just an interesting picture of what can happen if you choose not to do these types of treatments. This is Navajo Lake Campground on the Dixie National Forest in southern Utah. The left picture was taken prior to a spruce beetle outbreak, the right after the spruce beetle outbreak. If you look very closely, you can see the marker for the road as well as the corner of that picnic table in both of these pictures. Just a consequence of what can happen if you choose not to use these types of treatments. Here, obviously, significant changes in stand structure and composition, as well as reductions in shade, screening, and aesthetics. And here the agency actually was able to measure a decrease in visitor use as a result of those changes in stand structure and composition. Next slide. Get a lot of questions about the toxicity of these materials. Here are just three examples, different active ingredients, different products. On the left there is carbaryl in the 7SL formulation. In the middle is bifenthrin in the onyx formulation. And on the right is permethrin in the masterline formulation. A lot of people comment that the synthetic pyrethroids here on the right are much less toxic than carbaryl. Well, that really depends. For example, if you look in the middle, bifenthrin LD50 oral 153, that's lower than that observed for carbaryl in the 7SL formulation, and therefore it's actually in that context more toxic. To put all these numbers into perspective, caffeine in your morning coffee has an LD50 value of about 200 milligrams per kilogram. Next slide. Get a lot of questions about costs as well. Costs here really mostly tied up in labor, especially when working in remote locations, especially when you have to bring these large equipment into these remote locations, generally require several different people to actually accomplish these treatments. Next slide. Very effective, these tools. They greater than 95% efficacy. Residual activity varies depending on the system and other factors, somewhere between 1 to 3 years. So they sometimes have to be reapplied annually. In some systems, maybe every third year. But there are also other issues when applying bole sprays. These are just two examples of some of the many adventures we've had trying to do these treatments in remote locations. Next slide now. So a lot of information out there to help you with these types of treatments. On the right there, something you can grab online. The agency put together several years ago. It focuses exclusively on carbaryl, but is relevant to other active ingredients and products as well. Don and I and a colleague of ours, Steve Munson, have a book chapter, forget all of 2013, a little dated now, but provides a lot of information on the use of these types of tools throughout the United States. Generally, what we argue is hire or be a reputable contractor, have a representative on site when these types of treatments are being applied, collect daily tank samples, you get what you measure in life. For small trees, we argue that they should be treated from 3 distinct faces. On larger trees, from 4 distinct faces. That just increases the probability that you're getting complete coverage of the bole, and you generally need to do so from the root collar to the middle of the crown. Retreat according to the desired length of protection. Again, that varies a little bit, but generally between 1 and 3 years, depending on the active ingredient, the product, the bark beetle species, the tree species, abiotic conditions, as well as several different factors. And then obviously there are other considerations such as buffers and various environmental concerns. Next slide, Don. I think that may be you.
Yes. Thank you, Chris. Appreciate it. Just a couple comments regarding pheromones or semiochemicals and bole sprays with regards to the Southeast United States. For the most part, neither one are used very often for different reasons. Verbenone has been shown to be generally effective against southern pine beetle in managing or directing the bark beetles to stop attacking trees. However, there's an issue regarding the formulation and the costs associated. So for the most part, it is not used in the Southeast for southern pine beetle. And of course, right now, southern pine beetle populations are very low. So that's one reason. Regarding bole sprays and the like, carbaryl is actually ineffective against southern pine beetle. They apparently are able to detoxify the chemical, making it again ineffective. For the most part, most people do not attempt to spray. There are large numbers of trees in the Southeast, so tree value per se is less than what is observed out west. So for the most part, spray applications are not used either. However, there are situations, seed orchards, certain plantation situations, urban forests. There is occasional interest in trying to protect trees. When I started working for the Texas Forest Service, the standard was to spray trees to protect them against different insects, not just conifer bark beetles, but also coat and seed insects or gypsy moth or Lepidoptera defoliators, things like that. But over in the early 90s, the general stigma of spray applications was becoming more and more prevalent. People were trying to get away from spray applications, the limitations associated with drift, non-target effects, things like that. So I became interested in the prospect of using systemic pesticides as a way of protecting trees. What is a systemic? A systemic is a pesticide that is water soluble, that is able to be absorbed by the plant via the roots or through the bark in some cases, or the leaves. Or in some cases, some products you have to actually inject into the vascular system in order to get the product in. Once in the tree, these active ingredients are transported within the vascular system throughout. And when an insect, disease, or like attempt to attack or infect the trees, they come in contact with the active ingredient and are killed before any damage, or hopefully any damages occur. So that being said, systemics have the potential to reduce potential pesticide loads considerably compared to spray applications or drenches and things like that. There's no need for large equipment, spray equipment, because you're putting all the active ingredient into the tree. There's little or no worker exposure, no drift, no leaching into the ground. Because there's no photodegradation or microbial degradation, these treatments tend to last much longer compared to many of the foliar or bowl sprays. Because you're not spraying, there's a larger window of opportunity to treat trees. There's no impact by wind or rain. So there's a number of advantages that are observed with systemics. Moving on. Let's see. Okay. Not moving on. There we go. So there have been a number of attempts to use systemics in the past to protect trees against a number of insects, including bark beetles. And so you can see that acephate, azadirachtin, imidacloprid, oxidon, methyl, they've all been attempted to or applied to trees into the vascular systems, but largely have proven to be ineffective. There's certain reasons for that. There's limited toxicity to the target insect. There's concern about where this chemical is moving within the vascular system. Many of these chemicals are xylem mobile, but not phloem mobile. Phloem is where the insects are burrowing and creating galleries. So if the chemical is not moving into the phloem layer, then obviously the chemical is not going to have an effect on bark beetles. And similarly, there's other factors, abiotic, temperatures, time of the season, in certain cases. These factors influence the effectiveness of treatments. So when I went to or started working with the Texas Forest Service and the cooperative, I started visiting and talking with David Cox with Syngenta. He kind of let me know about some of the new chemicals that were coming down the development pipeline. And one of these was Emamectin benzoate. It's a lactone derived from ivermectin from a soil microbe. It disrupts the electrical response within the insects and causes paralysis. But he was indicating that this active ingredient was moving well within pine or conifers, and it also had very good activity against Lepidoptera or caterpillars. And one of my targets was coneworm within seed orchards. And so in 1997, we attempted to treat some trees in a seed orchard and found that the treatments were very, very effective. Turns out that in some of the trials, we were seeing upwards of 6 years protection against this coneworm, and to a lesser extent, seed bug problems. Unfortunately, the seed orchard market is very small. There was no interest by Syngenta to register this product. So it was, we were grasping for straws. We did know that in some other trials in Japan that this chemical was active against pinewood nematode. So again, here we see good activity within the pine and extended longevity of protection. Then in 2003, we were again grasping at straws. We tried injecting some Christmas trees in Virginia, and we then exposed some of the twigs from the treated trees to Paley's weevil, and found that many of the adults that were feeding on the treated twigs succumbed to the treatment. So guess what? Weevils and bark beetles are very closely related. So here we have a potential treatment to protect trees against bark beetles. And as we've described already, there are a number of bark beetles that are killing millions and millions of trees, and but no systemic treatment for protecting trees. So let's see, in 2004, I set up a trial in Texas, and where I treated a number of loblolly pine, 2 groups, and one group we periodically felled the trees and exposed logs from those trees to Ips Engravers. And here we see logs that were exposed after just 1 month post-treatment versus untreated logs on the left. And you see that for the most part, we get the same number of attacks, the red dots, but the Emamectin treated trees completely suppressed attack success of the Ips Engravers, versus the untreated checks. You see all the galleries, and a large amount of brood was produced. No brood was produced with the Emamectin benzoate treated trees. Similarly, trees that were left for 3 months as well as 5 months all showed good protection against Ips. The second group was treated, and then we stressed those trees with a chemical, cacodylic acid. We then baited the area with Ips pheromones, and the beetles began to attempt to attack the trees. All of the untreated trees died. All of the Emamectin benzoate treated trees survived after 4 months of baiting. So this is the first instance, This is the first demonstration of efficacy of a systemic for protection of individual trees against bark beetles. And this study was published in 2006, excuse me. And, so Ips Engravers, as we know, they're attacking stressed trees. Well, what about Dendroctonus? These are more aggressive. Would this Emamectin benzoate injection treatment provide protection against some of the more aggressive Dendroctonus species? So Chris and I initiated 3 different studies, one of which was in California on ponderosae pine, trying to protect trees against western pine beetle. We injected these trees with Emamectin in 2005, then proceeded to bait these trees with their pheromones, frontalin and other host volatiles. And for the next 3 years, we baited every year, 2005, 6, and 7, and then looked at the survival of these trees over time. The bottom line was that nearly or close to 50% of the untreated checks died, whereas only 1 out of 30 of the Emamectin benzoate treated trees was killed. So over that 3-year period. So very, very good efficacy against this particular insect. Additional trials were attempted with mountain pine beetle and spruce beetle. And particularly the mountain pine beetle was marginally effective. The spruce beetle trial was a total failure. And we'll discuss some of the reasons why in just a few minutes. But over time, we've done a fair amount of research, and Chris and I have put out about 13 different publications on systemic injection treatments for protection of trees against different insects, 9 of which now are, I'm sorry, I didn't slide that. Okay, so fair number of publications on the effectiveness of systemic treatments against bark beetles and the like. Some were very successful, some not so much. One of the factors that we learned that need to be considered is the fact that this, again, insect carries with it several different fungi, symbiotes. Ophiostoma, Grosmanii, Leptographium are all fungi that either are carried by the insect in mycangial pouches or on their body. And when they attack the tree, they inoculate the tree with these different fungi. And for many years in the past, it generally was considered that the blue stain was not really important in the attack success of the beetle. However, that's not necessarily the case. We have done some research recently where my colleague Joe DeCola inoculated, and his co-author, come on, I apologize. So they have inoculated pine seedlings with some of these different species of fungi, and found that at least one of the species was actually quite pathogenic to the seedling, causing a fair amount of mortality. Upon application of a fungicide called propiconazole, we determined that this treatment or this fungicide was able to prevent mortality of the seedlings. So some of the an additional trial that I set up in the South. Why? Okay. Trial was set up in Alabama with southern pine beetle on loblolly pine. We treated trees with emamectin alone, emamectin in combination with propiconazole, or propiconazole by itself. And the emamectin, and like the trials in the West, we baited these trees annually. And the emamectin was able to largely protect the trees for 2 years before mortality exceeded our 20% threshold, whereas the combination treatment of emamectin plus propiconazole was able to protect trees for 3 years. So we do see an advantage or a benefit of reducing the infection of or inoculation of the trees with blue stain fungus. We conducted a similar trial with spruce beetle in Utah, where we compared emamectin alone or in combination with propiconazole or untreated. And you see the untreateds are heavily infected with blue stain, whereas the combination treatment was able to largely prevent the level and extent of blue stain fungus. So given large populations, we would generally recommend the use of a combination treatment. Under lower populations or less aggressive species, we have found that emamectin by itself is effective enough without adding propiconazole. So, however, as I mentioned previously, all these initial trials were conducted. We were conducting very conservative trials where we're forcing beetles to attack trees using baits on an annual basis over 2 or 3 years. This is really unnatural. Normally, beetles in an area will be of high enough population to attack a group of trees for a year, maybe 2, but very rarely 3. So, and again, we are forcing beetles on to attack these trees over an extended period of time each year. So, again, unnatural. More recently, I wanted to look at the possibility of treating trees either alone, with emamectin alone or in combination with propiconazole, and see how these treatments fare against natural beetle pressures. So last year we set up a trial in Alaska looking at emamectin and propiconazole, and now we're allowing the natural populations to move into the area and challenge the treated and untreated trees. Last year, the populations were just starting to move in, so we didn't see much of any activity. We're hoping that beetle populations will build up this year, and maybe we'll see some higher levels of attack or challenging. So let's see. Okay, so again, we treated in 19, not much activity in later in the year when the beetles emerged. We're now waiting for the second season, and we'll follow it into next year as well. So stay tuned. So in conclusion, we have found that emamectin benzoate is highly effective against a number of different bark beetle species. Generally 2 to 3 year protection against southern pine beetle, western pine beetle, 2 years against mountain pine beetle, and 2 years against spruce beetle. The addition of propiconazole can benefit or improve efficacy or protection against trees, particularly at high beetle population levels. So a combination treatment may be justified under certain situations. But we have found through the years and in the various trials that there are a number of different factors that play into how well these systemic treatments fare. Temperatures, elevation, time of year, when is the insect active versus when are you treating, a large number of different factors. And that being said, okay, to make sure that you're getting the product into the tree, there's a number of different factors that will influence the receptivity or the movement of the product into the tree. Obviously, equipment and formulation are very important. ArborJet has spent years designing formulations so that they're not phytotoxic, that they do flow well into the trees, even conifers that have very small tracheal tubes. Our equipment has evolved over time such that we can now treat trees under 10 minutes. Moderate sized trees of 16 inches can be treated in about 10 minutes. However, there are always physical problems with trees, wound sites, insect, compacted soils, just general physiology of different species of conifers. Then you have the temperature extremes, moisture extremes, the influence of wind on tree translocation, Again, the vascular characteristics of the trees, whether in oaks, we have very large ring porous vessels that take product very well, whereas conifers have tracheal tubes, very constricted, require higher pressures to push the product in. And of course, there's applicator skills that are very important. And so, as I mentioned, we through the years, we've determined that it's, we have to keep in mind the biology of the insect, the biology of the trees. Under certain insects will attack low on the bole, so that we have to inject at closer intervals around the base of the tree, whereas other that attack higher up into the crown or the bole, we can space out the injection sites farther. We've determined for certain species when fall applications is best versus spring applications. In many cases, early morning applications when the tree is actively transpiring is most conducive to getting the product into the tree. Out west, where we have very high dry temperatures, the timing in a given day is more important. As it heats up above 85 degrees, trees tend to shut down to conserve water. So obviously, if the trees close their stomates, you're not going to get any movement of the product into the tree. So under certain situations where, particularly in urban, suburban environments, you can irrigate the trees to try to promote translocation, but that's not always possible out in the forest. Recently, Chris and I and Steve Munson have put together another publication where we've evaluated bole injections for protecting spruce against spruce beetle. And in this publication, there's a table where we list out some of the more important bark beetles out west: western pine beetle, mountain pine beetle, spruce beetle, and some of the recommendations on when and how to treat trees to maximize the effectiveness of these treatments. So stay tuned. It should be coming out in July of 2020, Chris. So with that, Chris and I would like to acknowledge, and we can't name everybody, but numerous colleagues and experts that have worked with us over the 25, 26 years to help us with these studies. A large number of different support groups have provided funding, as well as agreements with a number of different chemical companies, ArborJet, as well as USDA Forest Service. Chris, thank you very much for listening. Chris, do you have any comments? Other comments?
No, I really don't think I have anything to add on. Thank you.
I apologize for the delays and the problems with the slideshow, but Zach, do we have time for questions or?
Of course, we have as much time as you're willing to give. I only found one question through here, and before I ask, I'd like to say thank you to both of you for putting together this presentation. And Chris, especially, being out on the West Coast, and I don't know if you're in lockdown still or what, but I appreciate the time, and it's good to finally put a face to the name. Don talks about you a lot. Most of the time, it's in good references. So I'd like to say thanks to everyone for joining us.